Pre-calc, this is lesson 1.3, day 2.
Yeah.
And we are going to factor today. Yesterday we multiplied, today we're factoring. The first thing you should always do when factoring is to do this step. And that is factoring out any common terms. So I'm hoping you guys are sitting here looking at this going, not a big deal. So, looking at the first one, what can we take out? 3x. So if I take a 3x, what's left? X minus 2. Moving on to the second one. It's a little bit bigger. Probably a little bit more troublesome, but shouldn't be too much. What would this be? 2xy squared. And what would be left? 4x cubed plus y squared. Now, we just did that really quick. Probably all of us get it. But I want to put something behind this, as in, what exactly are we doing? What are you thinking when factoring out common terms? Like, what are you trying to say to yourself? You're like, self, this is what I need to do. Or this is kind of the rule. Anybody have one? How did you guys know that it was a 2xy squared or it was 3x? Yeah, every term has it, right? I like to sometimes think of it as, we're all donating to the contract fund today. So everybody take out your wallet and we're going to give what everybody can. That's what's happening, right? So one kid pulls out their wallet, pulls out a $50 bill, and I'm thinking, oh yeah, I'm going to get $50 from everybody. The next student pulls out their wallet, all they have is a $10 bill. So that means now everybody at most can only give $10, right? And then the next kid goes and opens his wallet, moths fly out, and there's nothing in there. So now no one gets to donate. There's no commonality. No one has to give, right? So it's kind of what everybody can donate. And then when I do take it out, what am I doing from there? How did I get the remainder of that? How did you get the inside part? How did you end up with a 4x to the third? What are you doing? You're not multiplying, you're dividing. You're dividing it out. Okay? Most of us get that. No big deal. So, the next one I wanted to tackle here is factor by grouping. Factor by grouping happens when you have 4 terms, sometimes 6 terms, sometimes even 8 terms. It gets more difficult then. But most of the time when we do this, it will be of 4 terms. I'm going to make an adjustment on one of these problems. I realized that I erased it. We should have a 6 on the second one to make it work. Instead of a 4. If we would have left it with a 4, it would not be factorable. And we'll kind of talk about that when we get to that problem. So I put 3 steps to this. I want you to, number 1, place parentheses around the first 2 and last 2 terms. Add to that step that you include the sign in the second group. I'll show you guys what I mean by that. Because taking the sign with it is kind of important to figure out what it's going to be between the outside terms. Number 2, at that point you have 2 sets of parentheses. You need to factor each set so that you get the same thing remaining. And what you do with that remaining set, common set, is you factor it out, leaving you the stuff on the outside of the parentheses that you push together. So, let's attempt the first problem. The first problem, step number 1 says, place parentheses around the first 2 and last 2. I said add the sign with the second group. Does everybody see that the sign here in the second group is a plus sign? It's plus 4x. I want to put that in there. Because the question I need to ask myself, am I pulling a positive 4 or a negative 4? Because sometimes it is negative, sometimes it's positive. So that allows me to keep my sign in place. Okay? So, what can I factor out of the first group.
X squared.
X squared. And that leaves me with x plus 1. Now, sometimes you do, sometimes you don't, have a lot of choices for that second group. But our goal is to make the inside of that second group, the side of the parentheses, the same as x plus 1. So what number would I have to take away? Or what would I have to take it away to make it a 4? Not just a 4, but a positive 4. That will help us a lot. Put a positive 4 out, which leaves me with x plus 1. Do we have something in common? Yes. What's common? So I'm going to take the x plus 1 and factor it out, leaving me with x squared plus 4, or the outside stuff, I'll just push it together. You have now just factored by grouping. Not so bad, right? Try the second one on your own. We'll come back to it. Parentheses are on the first two, yeah. Second two, yeah. What can I factor out of this one? X squared. What's left? X minus 2. Second group. Negative 3, because it leaves us with a... We try to engineer that to happen. So it's x minus 2 times x minus 3. So we've done this before, I hope. Hopefully it brings back some memories. Some other things maybe we should talk about here real quick. We'll do that on the next slide. Notice that I did change the original problem. So let's talk about what happens if I didn't change that. What if I left it as a 4? On that second group here, if I change that back to a 4, can I actually factor anything out?
No.
What's the only thing that's common? A 1. So that would be an x minus 1 or x plus 1. Is that the same as x minus 2?
No.
So that would tell you it's what? Not factored. Okay. Now, there's a difference here. And I had to explain it to first hour, was the fact that in this case, if I asked you to solve it or factor it, maybe you can say no solution at that point. But if this was set equal to 0 and it was an equation, just because it's not factorable doesn't mean there's no solution, right? There's many other times or places this could cross 0, just not nicely. So you may have to use a quadratic formula, you may have to use synthetic division, you may have to use something like that, or graphing calculator, so forth. So be careful when you say no solution. It matters what the question is and how you answer it. So let's move on to the next, I would say easiest factoring is factoring quadratics of ax squared plus bx plus c. I call these ones the next easiest. I think factoring out common terms is the easiest thing to do. The second one is a quadratic when a is equal to 1. I gave you guys a couple steps there. Find the factors of c, use those factors that will add up to b, and then place them into the brackets or the parentheses, right? Standard. We've been doing that for months or years, I guess, like, cumulatively, right? So, I recognize a is equal to 1, so I find the factors of 12. What are the factors of 12? 1 and 12, 2 and 6, 3 and 4. Guys, I sometimes like to list all of them, because sometimes there's more than one option, and you have to worry about signs. Now, this is a positive 12. So, when I go to make my brackets, remember how I get rid of my brackets is to FOIL. So eventually, I need to multiply those last two numbers together to get to 12. That's why we're looking for the factors of 12. We also take those last two numbers and multiply them with x's, the i's and the o of FOIL, to add them together. So, all of those pairs, when multiplied, give me 12, but only one of them gives me 7 when I add them. And it is 3 and 4. And then we have to decide. They multiply to a positive. How do you get a positive when multiplying? Positive, positive, negative, negative. The middle is positive. So the middle means both of those terms have to be positive. You're done factoring. Moving on to the second one. 45. 1 and 45. 2? No. 3? 15. 4? 5. Okay. Which pair can give me a 12? 3 and 15. So, x, 3, 15. Now notice that 45 is negative. That means one of them is positive and one of them is negative. The middle's negative, so the bigger one is negative. So negative 15 plus 3 will give you a negative 12. Done. How do I know if I'm right on any of these? FOIL. Now, this is just factoring. Eventually, you're going to have to solve these quadratics, which means they're going to be set equal to 0, right? Which means our factors are set equal to 0. How do we handle that?
Just separate the 2. As long as 1 is equal to 0, you multiply.
Right. We set our factors equal to 0 and we solve them, right? X equals and x equals 15. So if you had to solve by factoring, you just take the factors, set them equal to 0, and you're good to go. It's kind of nice. We ready to move on to the harder quadratics? Yes?
Yep.
So when a is not equal to 1. So I have a couple steps there for you. That's nice. For these ones, you need to find the factor pair of not just c, but a times c that will add up to b. Use these factors to split up the b term into 2 terms. And then just factor by grouping. So if you need to, revert back to grouping steps. So 6x squared plus 7x minus 5. So I'm going to ignore the fact that sometimes they're positive or negative right now and just do 6 times 5. 6 times 5 is 30. And I'm just going to find the factor pairs of 30. 1 and 30, 2 and 15, 3, 10, 5, and 6. Correct? Which one of those pairs could give me a 7? 3 and 10 is the only one. So that's the one I'm using. What I'm going to do then is I'm going to rewrite the problem. And the order does not matter. I can put 3x first. I can put 10x second. Or vice versa. It still will work. Now, it has to give me a positive 10, or positive 7, sorry. So which one's the positive and which one's the negative? The 10's positive. Let's start off with that. Doesn't really matter. And if I subtract 3x from there, 10x minus 3x is 7x. And now you have how many terms? So, factor by grouping. If by chance none of the pairs here can lead you to a 7, it's not factorable. Isn't that nice? Back when I was your age, I was given the fact that you had to take the factors of 6, take the factors of 5, and make the brackets and start filling them in until you find a pair that work. 6 and 5, not too bad. Look at 9 and 45. How many pairs of 45 are there? A decent amount, right? How many pairs of 9? A couple. So you might have like 10, 12 combinations that I would have to check. And then the teacher goes and gives you one that doesn't work. You have to test all 12, not forgetting which ones you tested, before you say it's not factorable. This one, you make a list. If you can find a pair that works, it's going to work. Group it up. What can I pull out? 2x. What's left?
3x plus 5.
And pulling out negative 1. See? That's why I put the negative inside, so you recognize that it's a negative there, right? And that means 3x plus 5, and so it must be 3x plus 5, that's a bad plus sign, there we go, and 2x minus 1, you have now just factored it. Awesome. I'll give you guys a couple seconds to try the second one on your own. Okay. So, what do we get? What's 9 times 45? Equals 405. That means 1, 405. 2? No. 3? Yes. What? 135. 4? Probably not. 5? 81. Getting closer, I think. Yeah, we got to get to 36. 6? No, I don't think so. 7? 8? 9? 9 and 45. 10? 11, 12, 13, 14, 15? 27. I think we can stop. I think do we all see it? It is going to be using the 9 and 45. If I have a positive 9 and a negative 45. Now notice, hey, wait a minute, my first term is a 9. So why don't I put the 9s together, and I'll put the 45s together. Is that all right? So 9x squared plus 9x minus 45x minus 45. That's pretty easy to figure out what's common, right? Factor it by grouping. Let's group it. Get your group on. Oh, wait, I probably can't say that. What can I take out? 9x, what's left? X plus 1. Take out of the second group. Negative 45. Let's get x plus 1. So therefore I get x plus 1 times 9x minus 45. Are we done? We're not completely done, are we? Because when you factor something, you need to factor it completely. What can I do? Take a 9 out of that second group. So the 9 is going to go way up front. X plus 1. Which leaves us with x minus 5. Now you are done. What should we have done in the very beginning, guys?
Just
take out a 9. If you would have took a 9 out in the very beginning, what's a going to be? 1. And then all you do is find the factors of 5. I think that would have been pretty darn easy. So you didn't have to go through all these steps. Guys, again, step number 1 is always factor out the largest term first. Okay. This stuff is the difference of squares, the sum of cubes, difference of cubes. I have all 3 formulas up there. You guys have seen them. You have worked with them before. Basically, I'm giving you the same 2 steps. Find out what's being squared or cubed, and then that gives you the A and the B to use in the formula. So I'll give you an example of each type here. This is how I do it. I will sit back and say, okay, I see that I have 2 terms. 2 terms means it's either a difference of squares or difference or sum of cubes. That's it. Checking, can I pull or factor anything out of those 2 terms? No. No. Okay. Well, since it's x squared, maybe it's a perfect square minus a perfect square. Is 81 a perfect square?
Yes.
Okay, so this is the difference of squares. So I sit back and I ask myself, what's being squared? To get x squared. X. What's being squared to get 81?
9.
Guess what? That is A and that is B. Go to the formula. It's A minus B and A plus B. Can it be A plus B and then A minus B?
Yes.
Yeah, the order doesn't matter. Remember that. So this would be x minus 9 and x plus 9. Done. Do the same thing with part B. Part B, it's 8x cubed. Well, first of all, can I factor anything out? No. It's two terms, but I see automatically my eye is drawn to the x cubed. So therefore it can't be a square. It's a perfect cube. Is 8 also a perfect cube? Is 125? Okay, so set it up. Something cubed minus something cubed. What's being cubed? To get 8x cubed. 2x. 125? 5. You now know A and you now know B. Plug it into the appropriate formula, which is the second one, or third one here. Now, this is how it works. You only have to memorize one of these formulas, just know how it works. Because they're the exact same thing, it's just the signs change. The sign between the cubes is the factor that comes out. But then when you go to the quadratic, it changes to the opposite. So this is going to be a minus b, or 2x minus 5, times a squared plus a times b plus b squared. Now the question is, did you really have to write out that whole entire thing like that? Some of us, yes. Some of us, no. So we know it's going to be 2x minus 5. And what's 2x squared? 4x squared plus 25. You're done. Now, I have found that every time I've done this pattern, I always get a linear factor that comes out, and then I get a quadratic, and that quadratic always happens to have imaginary solutions. You will never be able to factor that part that's inside the largest sequences. This is done. You never have to go any further than this. Okay? So the last thing I want to talk about for factoring is what happens when you have ax squared plus 2ab plus b squared, or minus in front of 2ab. So instead of giving you two different patterns, you only have to remember one. This is called a perfect square trinomial. Perfect square trinomials are basically your binomials squared. When you factor or foiled the things that were just 2x plus 2 squared, hopefully you found that certain things happen. And we were able to memorize factoring them real quick. Is the first term squared, last term squared, multiply the numbers together and multiply by 2. Follows the exact same thing we did with the difference of squares and the different sum of cubes, as in, you look at a problem. And what I do is I look at this problem as our example and say, hey, it's a trinomial, and 4x squared is a perfect square. 9's a perfect square, yes? So maybe it fits the pattern. And so I write the pattern down. Yes, this does help when you write down the pattern. So you ask yourself, what's being squared to get 4x squared? 2x. What's being squared to get 9? Just move them in. So 2x and 3. What's 2 times 2x times 3? Does it equal the 12, the middle term here? Yes. Therefore, it is a perfect square trinomial, which means that it's just 2x plus 3 squared. Done. It's the first and last term that you found squared. Add it together. Okay? Pretty simple. Your homework is page 33 of 1.3, 35 through 91 every 4, and problem number 93. Have a great day.